Okay, so the next question that we got on the menu today is how do we calculate the momentum of a photon? Okay, so um, the short answer is that it is really just it's really just this equation. The momentum p is equal to h divided by wavelength, where p is the momentum, h is Planck's constant, which is 6.626 times 10 to the negative 34 joule. I think it's joule seconds. Let's search that up real quick. What's Planck's constant? Planck constant. Meter squared per kilogram per second. That's the same as joule seconds. And here, this is a wavelength. Okay, this is the real equation that you want to use, but I'll show you how we got to this place in the first place. Or we got to this point in the first place. Okay, so a long time ago, there was a dude named Einstein who made this moderately famous equation. E equals energy is equal to the mass multiplied by the velocity of light squared. This is mass energy equivalence. Thanks Einstein for figuring that out. It's a pretty cool equation. So this is Einstein mass energy equivalence. And then we have momentum of a particle, which is just P equals mass times velocity. Okay, if we were to isolate mass out of here, we would have mass equals mass equals energy over c squared. Sub that into here for mass. The momentum is equal to the energy that it has divided by c squared, which is the speed of light, divided by, or multiply that by the velocity of the particle. But since v is equal to c, we can simplify this to do that. So we will just have E over C. Okay. Yeah, and now the energy of a photon is given by E equals Planck's constant h multiplied by the frequency. Now here they use V. All my life I've been taught to use F for frequency, but I've seen some people, like more often than I'm really comfortable with, using V for frequency. I guess that works, but in my opinion, F makes a lot more sense because you don't use F for other things like velocity. So that's just my opinion. Yeah. Okay. So we can sub out HF for the E in here. So P equals HF over C. And then we know from our universal wave equation that velocity is equal to frequency times wavelength. And if we wanted to just get the wavelength, or just get the frequency, because we're trying to sub out that f to be with respect to the frequency, it's going to be v over lambda is equal to, v over lambda is equal to f. Stick that into here. P equals h v over lambda c. But we know that since c is equal to v, we just get P equals h, Planck's constant, over the wavelength. Okay, so that's how we get the momentum of a photon, just by knowing its wavelength. Okay, so you can see where that equation comes from. We combined a lot of different ideas: mass energy equivalence, momentum of a particle, energy of a photon, and the universal wave equation. Put all those puzzle pieces together, and then we can get here momentum of a photon given the wavelength. Yeah, spelling. Okay, so yeah, that's exactly how we came across this. Okay, so yeah, above solution is good. However, using f to represent frequency would be better, as the v used can be confused with velocity or voltage. Okay, groovy.